You are welcome to the Ambassador tutorial. In my class today, I'm going to be solving a question on organic compound, and let's go to the board. In this question, it is naming of organic compound, which is our CHM 102. So the question says the IUPAC name for is, that means they want us to name this compound we are seeing on the board. So how do we name this compound? The first thing you notice is that you see that those compounds are actually having a condensed structure. It means you can't know where is the hydrogen attached to, you can't know where is the methyl attached to. So my advice is that let us firstly find a way we split those condensed structure into a structural formula. In that sense, I can try to look at this carefully. You look at this case from here, try to bring it out. When you try to bring it out, you see we have that C connected to just one hydrogen atom, then this C connected to just one hydrogen atom, then under it we have a methyl compound, then the other C, which is the terminal C, is having this structure. So what happened to this one? For the case of this one, it means that this CH3 is in two molecules and is attached to this carbon. So in this case, I can put it here, CH3, then on the other side, CH3. Now I've actually broken down this condensed structure to a structural formula, so we can now name. So how do we name this? The first thing is to count the longest carbon chain. So looking at the longest carbon chain, picking from my left hand side, I have 1, 2, 3, and 4. Anytime we have 4 carbon atoms, it's usually called butane, or just call it but. 4 carbon atoms are called but. And the next thing to get is to find the functional group. Where do we have the functional group? It's at this area we have the functional group. How do I know? Functional group are either atoms or bond attached to an organic compound. So this functional group is a common one, which is called, we have something like R combining with. This functional group is called carboxylic acid. Sometimes it's also written as RCOOH. So anytime we see this functional group, it's called carboxylic family. Most of the time, the family usually end up with NOIC. For instance, we can have metanoic, we can have ethanoic. As you can see, at the end of the compound, there's always this oil or stuff. So they are called carboxylic family. So in this case, if we are dealing with the longest carbon, which is but, it means that the parent name or the parent chain is called butanoic acid. How do I know? The first thing, we get the longest carbon chain, which is but, and we get the functional group, which is carboxylic. And I said that carboxylic usually end up with noic at the back of each compound. So that's why we call it butanoic acid. We're not done. We still have something to do, in the sense that, do we have substituents? Now, what is substituent? Substituents are atoms or group of atoms attached to the organic compound, not affecting the carbon chain. That means, if you look at this carefully, this is what I actually call the longest carbon chain. So what other things do you see is attached to that compound that's not really affecting it? We have this 1 and we have this 2. So, and what are they called? The substituents are called methyl. Anytime we have CH3 are referred to as methyl. Okay? You call this side so that I'm able to explain. Okay, so like I said CH3 is referred to as what? Methyl. And if you look at this carefully, the methyl is found when you start from your left hand side, from your right hand side, the methyl is found on carbon 2 and also on carbon 3. And likewise, when you start from your left hand side, the methyl is found on carbon 2 and also on carbon 3. In that case, if I want to name it, I would have called it 2, 3. But how many methyl compound do we have there? 2. That we call dimethyl. Then you name the what? The parent name, which is butanoic. So I'll call it 2, 3 dimethyl butanoic acid. So this is the name of the organic compound we have. So please do well to follow our channel and also subscribe to have notification of our latest video. Bye.